Hello everyone, welcome to this video. Today I have something super cool. You don't want to miss this, trust me. Now I want to show you the program quickly, then we're going to start writing the program. Now what does this program do? As you can see, we are generating keys and then monitoring the lifetime of the key. Now why is this important? So if you design any system, any kind of system that maintain encryption keys, it can be JWT, any kind of encryption key that requires expiration, you are going to need to do something like this. Now, where is this useful? When you want to test or simulate how you do key rotations, you want to be able to simulate when the keys expire and when you can generate new ones, or when the key expires, how the system reacts to the expiration of the keys. This is super important. We are going to build this simulation to show you exactly how that works. When I was thinking about it, I made some research into the idea. Let's start with this time dilation. So the idea actually, this is a very big idea in physics, and it is also a real thing because your GPS satellite and all that, they are doing something about it, So if you want to research it a little bit more, a little bit further, you can come to this article here. Now, in this movie Inception, you remember, if you have seen the movie, remember time is different at the different levels of the dream. This is quite interesting. It's so interesting how we take something from the outside world into tech, Even like, for example, Kanban. I think Kanban came from a factory production line in Japan. Ideas, abstract ideas that we can bring into our engineering process. Now, in Inception, time in reality, we know it is 60 minutes is 1 hour, right? Things like that, we know that is reality. But when you go into another level of dream, time is changing, and they are using this idea of time dilation. Super important. That is exactly what we are going to do in this video. It is about how you can compress time. That means, let's say 1 minute in our program. What does 1 minute mean? In 1 minute of real time can be 1 month in the simulation. This is how I brought the idea of Inception into the program. That, okay, imagine 1 minute outside in reality is like 1 month in the simulation. That is one level of the dream, and we can have different levels, right? But this program, we are going to focus on just compressing the time and then generating the keys. Now, let's get started. The first thing I want to do is to start with a key type, right? So let's start with a key type. And the key type, we are going to have the ID of the key. We're also going to have the created at and then the expired at. After that, we're going to need a key manager, which is responsible for coordinating the creation of keys, when the key expires and all that, right? So let's create the key manager, and then in the key manager we are going to have the keys, which is basically like the vaults. We are going to need a mutex as well to control access to this memory. We are also going to need the time scale, which is how much we want to compress the time. Basically, this is what controls the time. And what we are going to do in this program is 1 minute of real time is going to be 1 month in the simulation. And this is where it's important, like the most important part. That means when you are testing your key rotation, like your JWT, if you want to put this into an integration test, you don't have to wait for 30 minutes, 1 hour, or 30 days for the key to expire. You can let this program do the whole work for you by compressing the time. All right, and also the time the simulation is going to start. After that, let's create a constructor to create this key manager. Let's return it. I'm going to pass some of the fields in here. The key, we're going to make it, passing the time scale, and then the time the simulation is going to start is time.now. All right, next we are going to create the, we're going to start adding some methods to this object. I need to close this out. The first method we are going to write is the simulate time method, which is basically a replacement for this time.now. So instead of us depending our time calculation on this, we are going to now depend it on this new method. So let's go ahead and do it. Okay, we need to track the time that have elapsed since the start of the simulation. Then we need to construct the simulated time based on the time scale. Basically, we are going to multiply it, and then we're going to return it by adding it to the time start time. All right, so this is our simulated time. After that, let's add another method to create keys. Now, the lifetime in months of how many months you want this key to last. So if you want your key to be 1 month, 2 months, 3 months, you can supply that here. Now, something very important. If your program requires lesser time, maybe in days or in weeks or in seconds, you can do all that. You know, it's important. You can do all that. Okay, mutex. We need to control access to the mutex. Let's defer the unlocking of the mutex. And then, like I said, our noun is going to equal to this one. So let's put it. Now, I want to do something else here. Instead of creating 30 days as 1 month, so let me show you something. 1 month is approximately 30.4, so it's not 30 days. What we are going to do, I'm going to add some variations here, basically like 10%. So 10%, then let's adjust the months based on that. From there, we can use that to create the expired time. Based on this, we can now create the ID of the key, and then we can create the key itself. After adding the key to the vault, let's print out some message, and then we can return the key. Now, I want to explain something here a little bit. You see this ID that we've created, because we are basing the ID on the length. When we remove expired keys, this is going to affect the ID. That means it is possible for the ID to be reused. When you are building production level stuff, you want to use something more strong like UUID. I don't want to include any external library, so I am going to keep it this way. All right, let me close it up, and then let's add another one to check for expired keys. We still have to do the mutex again, normal thing, and then set our noun to the simulated time. Then we're going to loop. In the loop, let's check if the key has expired. We want to let's print out a message first, and then we can delete the key. Else, we can print out a different message. Great, right? This is all that we have to do for this one. The next method I want to add is to delete expired keys. Basically, we are going to delete the expired keys and return the total count. Let's see, do the mutex thing here. And then our time, of course. The count we want to use to track the total number of expired keys that we've deleted. Then loop is very similar to this method. In short, the delete that we are performing in this method can be removed actually, but let's keep it for now. So check if it is as expired. we delete it and we increment the counter, and then we just come here and return the counter. All right, so you see what we've done so far. Let me scroll gently to the top and then let's go over it. We have the key type created with an ID, expired at, created at, simple stuff. Then the key manager basically keep tracks of the keys that we are going to create. And of course, the mutex is to coordinate synchronization between the Go routines. The time scale, we are going to use this to, for example, set how we want to do the compression. Like I said, in our real world here, real time here, our 1 minute is going to be 1 month in the simulation. So this is where this is going to come from. And then the time we are starting the simulation, we added the new key manager. Then we created a simulated time. If you want, you can name it now or simulated now. Then after that, this function is used to create the key. I think the most interesting part in this function is that we're adding some variation basically to make it like maybe instead of 30 days, you get 31 days, and instead of sometimes you get 29 days, or you get the 30 days, in between like that. So minus 10% there. All right. And then after that, we added these two other methods that basically check for expired key and then delete. All right, so far so good. Now let's add one more method to print the status of the keys. Basically, this is for the output, what I showed at the beginning of the video. All right, so let's put the method here, print status, the mutex, as always, and our time, of course. You see, it's very similar. Now let's print some headers so you have some information. Let me show you quickly. Terminal, this. You see, key status, simulated time, and then the active key. So this is, we're going to print this, and then we're going to print this header, and we print the keys. All right, simple stuff. So those are the headers. Right after that, of course, we're going to check if we have some keys before we try to do anything. We print the headers, the key ID created at, expired at, and remaining. Now we're going to loop. In the loop, let's create a variable to track the remaining. So if it's still valid, we print the time, else we said it's expired. So we put a variable called remaining, and then let's check if it is expired or not, and then else. Okay, you see, then else we format it here. All right, looks good. After that, we can print the keys now, basically formatting it. So we print the ID, we format the created at and print it. Also the expired at, formatted, and the last one is basically remaining, and then we close this out. Looks good. After that, let's print out some dash 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 at the end of it. So very simple function, and then that is the end of it. Last thing we want to do is to take care of how we want to run the program in main. Now in main, we are going to have some flags that can be supplied from the command line. If you don't want to do that, if you want to hard code them, great. But I want to do the command line so that you can, in case you pull down the project, you want to pass in the arguments and you can test with different kind of settings. All right, basically what we are going to do is this. We're going to pass the scale, which is, I'm going to set to 43800, which is something I came up with just playing with the number based on the total 30 days, 30.4 days, making a month. So 1 minute of real time of our time is 1 month in the simulation. I've been saying it all over and over again. Then every 5 minutes, we are going to check if any key has expired and we can delete them. Every 30 seconds, we create new keys. And then we are going to have like minimum and maximum lifetime of key that we want to create. So basically that's what we are going to do in main. So let's go ahead and do it. Okay, let's start with the time scale, which is basically set to 34800 by default, and I put some description here. After that, the check interval is basically how frequent We want to check for expired keys. We're also going to have the key gen internal, which is basically interval, which basically how frequently we want to generate new keys. You can pass this from the command line and test with different time. All right. And then the minimum lifetime and the maximum lifetime, which I set to 3 and 12. So we're going to generate something between 3 and 12 months. Okay, of course, let's not forget to pass the flags. And then let's create the key manager now. Remember, we have a constructor up there to create a key manager. Just on an aside, this asterisk we have here is not a multiplication sign. This is the referencing this pointer, because this time scale is actually a memory address. That means there is a value hidden somewhere in memory that this is pointing to, and this asterisk basically is telling us that, hey, go to this address and give me the value. So that's why we're doing it like this. All right, now let's loop. When we start the program, before the intervals, before the loop starts running forever, we want to create like 5 keys. So it can be 3 or anything, but let's create 5 keys to start with, to have something in the database. And then let's create the lifetime and also create the key. Now I am doing a little bit of randomness here to do the min and the max, but yeah, this is to just make the whole thing a little bit more natural. Okay, after this, now we have created 5 keys. Let's create some tickers. Basically, tickers are functions that receive signal when some time have passed. So for example, this check ticker is going to receive, it has a channel. It's going to receive a message in that channel every check time interval, which we have set to 5 seconds. So every 5 seconds, there is a channel here that is going to receive a message, and we are going to react based on that. Let's defer the stopping of the ticker. Let's also create another one for the key gen and defer the stopping as well. Lastly, when the user press the Control C to terminate the program, I want to receive that signal and print out a friendly message as well. So, and then of course we want to capture the signal. All right, let's print out the status of the key just for us to see something, the information that we've provided. All right, time to go into the loop itself. Now in the loop, we're going to need select, and select is a way for you to listen on multiple channels. So we have 3 different channels here possibly that we can listen to. So select is the best way to solve this problem. I think it's also, there's a way that if you don't want to use select, it's also possible to do some workaround. But look, this is a natural fit for select. All right. So the first case is basically the check ticker. This C is a channel. See, this is a channel.time. It's a channel of time. So we are going to need it. Let's check for the expired keys and then track the deleted ones. If anyone has been deleted, we sure want to print out some message and of course print out the status. After that, let's handle the second case, and that one is quite straightforward. You've seen it before. We created a lifetime. Again, we're going to create a key, print out the status. Then lastly, the third case is this channel. When we receive the signal, we want to handle it by printing out a message and the status. And let's return here. In a nutshell, I think this is everything. So when the program gets here, it goes on this infinite loop, and this continues here to hang until we get a message in any of these channels, and then one of these functions will be triggered. So this is the program. Let me save it. I want to scroll gently to the top of the program to look at the imports. Fantastic. I want to make sure that we are using this round v2, so that's why I scroll to the top, And then I'm going to go back again now to the button, and we are going to run the program. To run the program, I'm going to come here. I want to switch to bash because I have autocomplete. I don't want to show. Go run this. If there are no errors, and then let's see. Okay, you see some of the keys we've created. The five keys that we created when the program started, they are all here. 1, 2, 3, 4, 5. All right. But look at the number of days, it's quite big, so we're probably not going to see any of this expired like easily. But after 30 seconds, we are going to create another batch of the keys, and we'll see again. See, I think look at one has just been added. You see, we just added another one after 30 seconds, and then it's going to add another one again after 30 seconds. But what I want to do, just for us to see some of them expired, I'm going to modify the program a little bit. So let's come here and let's scroll to the top here. Remember, we can pass in some access, so we can say minimum life. Let's set it to 1, and then I think max. I think this is the right way to maybe like 3. Okay, good. Remember, we said that 1 minute in our real program is about 1 month, which is minus plus. I told you about the 10% variation thing. So let's watch how this happen. Let's wait for 1 minute for it to expire. So while we're waiting for it to expire, I want to talk about the next idea I have for this program. I want to write a simulation, just exactly what we have in Inception, to add different levels of dream to this program. So I'm going to rewrite this same program again, but from using Inception as the idea. That is where I got the idea from anyway, just to simulate that whole dream and how they perceive time differently in each of the dreams. And sometimes the dreams, they enter a limbo, and again, we can see how that works as well. So we have 7 active keys still. So good. Key 2 just expired. Key 2, let's look at key 2. And you can see the one with the shortest number of days. So after 1 minute, we see that in the simulation, 1 month has passed. This is how powerful it is. While you think the time is 1 minute in real life, in the simulation, 1 month has passed. In short, since I have been talking more, many more months probably have passed. So this is very powerful program, very powerful concept, and it's also super easy to write as well. So you can integrate this into your program, like your integration test, your simulations, your servers, and enjoy it. So thank you so much for watching. Just a quick comment on what I have planned. I have a networking programming videos planned where I'm going to teach how to design peer-to-peer networking Go. Very powerful video. We're going to do everything just like I did now from the scratch, and show you guys gradually how everything comes together. Thank you so much. If you like the video, do not forget to comment, give it a thumb up, and you can share as well. Thank you. Bye.